Hello everybody, this is Mrs. Slater and we're going to be talking about 14.2, still in arithmetic sequences. Before we begin, from Perks of Being a Wallflower is a quote, "We accept the love we think we deserve." And a joke for you, see if you can get it by the end of the lesson. A cowboy rides his horse in town on Wednesday, is there for one day, and leaves on Friday. How did he do it? I'll answer that at the end of the lesson. Before we begin the examples that are in your packet, I first would like you to write a couple things as far as definitions go, maybe on the right side of your packet before it starts the examples. So the first thing I want you to do is write down the arithmetic sequence. Okay, and they're a special type of sequence. Each pair of consecutive terms has the same difference. Okay, it is called the common difference. Okay, and that has a special variable to go with it all the time for arithmetic sequences. So if you see a variable d, that's what it's referring to. So if you ever want to do a test to see if it's an arithmetic sequence or any other type, you can test for arithmetic by taking, finding the common difference. So you would take the second one minus the first one. Or you could even take the third one minus the second one. As long as you're taking them and subtracting them in consecutive fashion, it would be fine. Or the 100th term minus the 99th term, and so on. So I think you get the idea. If you want to find out if it's arithmetic or not, you would have to do multiple of them and make sure that they all match. Okay, so a formula that we're going to be using today a lot, so I figure we'd go ahead and write that down now, is for arithmetic sequences only, a sub n equals a sub 1, and we learned yesterday that, in section 14.1 that means the first term plus n, meaning the number of the term, minus 1, and then we're going to multiply it by our new variable d, which means the common difference. Okay, so let's go ahead and go to the first example. So in the directions, it's asking you to find the first term, and it's also asking you to find the common difference. Okay, so let's first make sure that this is an arithmetic sequence and do the test. So the test is to take 112 and subtract the previous term. You end up getting 0.06. So now let's do another set, 0.18 minus 0.12. And this one may seem very obvious. Some of them aren't so obvious, so it's good to know what the test is. 0.24 minus 0.18, 0.06. Okay, so since they are all the same, I know for sure that this is arithmetic. Okay, now as far as the first term, this one is obvious because it is right there. So let's label it appropriately. First term is going to be 1.06. Now the common difference, because we did this test, we can tell exactly what that common difference is. It's getting it's adding 0.06 every single time. So that's all you need for that one. Okay, let's go on to the next example. So it is, again, let's do the test to see if it's arithmetic. And -6 minus a -9. Okay, that looks a little weird, so let's go ahead and two negatives make a positive, so you get an answer of 3. And then writing it horizontally even makes more sense. So -3 minus a -6, two negatives make a positive, you get +3. And then for the last one, 0 minus a -3. Notice again, I'm taking the second one minus the one previous before it, and you get 3 as well. So from the sequence, you can see that the first term is -9, and the common difference is 3, because that is what we did when we did our test. All right, so the next one's going to be the trickiest of all, because you've got these fractions. And the fractions are going to be worked the same exact way. So let's do the test. We take 1/10 minus 3/5. And as you guys all know, we have to subtract by getting a common denominator. And you get -5/10, which then reduces to -1/2. Okay, so let's do the next one. We have -2/5 minus 3/5. Nope, sorry about that. It would be 1/10 minus 1/10. And then if we get a common denominator, it would be 10, and the top would be 4. So you get -5/10, which is a -1/2. Okay, so this is looking good. And we'll just go ahead and stop there because we can see that the first term is going to be 3/5. That we can just find right there. And then the common difference is -1/2. Okay, both of these things you're going to have to use a lot when it comes to examples 4, 5, and 6. So revisit those again if you ever are having difficulties. Let's go on to the next example. So in number 4, you can already be notice that it has arithmetic sequence. So we already know it's arithmetic, so we do not have to do the test. But they want to know what the 11th term is. Now, yes, of course, you can make your list, find out what the common difference is by taking 0.12 and then subtracting the previous one, and to get the 0.05. So you can find the common difference, and then you can go ahead and add 0.05 to each one until you get to the 11th term. So I'm going to stop you right there and show you a more efficient way. So you can do that. I'm not saying you cannot do that. But the more efficient way is to use a handy-dandy formula. All right, so that was the one that I told you at the beginning of the video. So if you have A sub n equals the first term plus n minus 1 times d. If you write that down, now it's all about just plugging in some numbers. Okay, now the n is representing the term that you're on. So that'd be A sub 11. So we're finding the 11th term. Okay, and then the first term of the sequence is 0.07 plus n is back again. That's going to be 11 minus 1. And then the common difference we found over here, which is going to be 0.05. And with order of operations, if you want to push pause and go ahead and figure that out, you can. Otherwise, you should get 0.57. If you don't get that for the 11th term, then that could be a good question for me tomorrow. You can ask then. Okay, so let's go on to the next one. And again, you're dealing with fractions, but don't let that alarm you. Let's go on and talk about what the common difference is going to be. So 7/3 minus 3, and if we get a common denominator, it would be a 9 over 3. So that's going to be a 9. And then you get a -2/3 as your common difference. Label these as you go so you can be comfortable with all the labels that go on in the formula. Now we're going to use the same formula again, A1 plus n minus 1 times d, and we want to find the 14th term. So now n is going to equal 14. The first term is 3 plus 14 minus 1 times the common difference of -2/3. All right, so then when you do the math, you end up getting 3 plus 13 times 2/3. And after combining doing order of operations, you end up getting -17 over 3. So again, this is describing what the 14th term is. A sub 14 describes the 14th term. Okay, so let's go on to the next one. Okay, you can use the formula again for this, but we're going to use it in a little bit a different way because they're asking the question in reverse. It's asking you what is the term. So this is going to have to be left open for a second. We know the first term plus n minus 1 and then d. Okay, do we know what the common difference is? Yes, because we did this 2 times ago. So I'm going to go ahead and replace that with 0.05. What also we know is that even though you cannot tell what that is, we don't know what term it is, but we know that that's 1.67. Our ending result is supposed to be 1.67. Okay, now by leaving n open, we are finding the term that we need since n is the only thing left. All right, so after you subtract, you end up getting 1.7, and then n minus 1 times 0.05. And then after dividing, you're going to get 32. And then adding, you're going to get a total of 33. Now what that means is that 1.67 is the 33rd term in the sequence. So you can also find out what value it is. Number 7, I want you to go ahead and push pause, and I would like you to figure that one out on your own, and then the answer will be up after you push pause. So hopefully you got negative 27 is the 46th term. Okay, so the next one's a little tricky, but I think if you think of it as just a variation of the formula we already know, you will be fine. Okay, so I want you to notice something about where the placement is. Notice that the ends are here, okay, and then also notice that a sub 1 has minus 1. Okay, so with this one, since I'm not given the first term and I'm not given the distance, I'm going to manipulate this just a little bit. I'm going to keep a sub n the exact same, and I'm going to change this to a sub m, meaning another term. Okay, so if this one is n, and we've got the match that we have up here, this has to be minus m times d. And we'll be able to use this to find the common difference. Okay, so let's plug in some numbers. We know that the 17th term of the sequence is 25 thirds. So I'm going to go ahead and put in that a sub m is 25 over 3. Let me get some room here. And also that it is the 17th term. So 17 is going to go right there. Okay, I also am given that 95/6 is the 32nd term. Now the only thing left is d, and I want you to push pause and go ahead and solve that. All right, hopefully you got 1/2 as your value of d. Now we can use that in the regular formula that we are comfortable with, and we do not know the first term, so that's going to be what is left open. So we can put the 95/6 and the 32 in here, or you could put the other one, okay, the 25 over 3. Okay, so that's 32 minus 1 is back because we have the first term, and solve for a sub 1. Push pause and solve for a. Okay, so after solving a sub 1, you get 1/3. Check the math. I've got some scratch work off to the side. You can check that as well. So we've definitely done that problem. So let's go ahead and move on to the next one. Tomorrow I'm going to tell you a story about Carl. So look him up, see if you can find that story I'm talking about. But that leads into the next formula, you can ignore that, which is to use find the sum. Now 14.1, we talked about how we can do a sum, and we can go A1, A2, and add them all together, all the way to 35. Now I'm sure that's not something that you want to do on your spare time. So we have come up with a formula, and Carl helped us with that. So the formula, go ahead and write this down, and then push pause. Okay, so let's go ahead and use that formula for this one. It is saying that we have the sum of 35 numbers. So n is going to be 35 in this case, 35 over 2. I'm using the formula up here to find the sum of these numbers. And the first term, or a sub 1, is going to be 1 plugged in for n. So that gives me 3, which is a total of 4. The last term, or a sub 35, we take 35 and plug it in, and that's going to give us our last term. And that value is 106. Okay? And if you do order of operations, you end up getting 1,925. Now that is going to be about all I can do for today. So I want you to do number 10 on your own, and then we'll talk about Carl, and we'll talk about George Renier tomorrow when we come to class, which is my dear old dad. Alrighty. Ta-ta. And the answer is Friday.